Good, we are recording. And Tina, you're supposed to have told me that. Excuse me? Oh, thank you. Yeah, that was what I was supposed to be doing. Now, if I can get this to. There, hopefully everybody can see the screen. Bingo, thank you. A little practice getting set up here. Okay. We are talking about injection still this week. We'll move on to cross-site scripting and other stuff next week. A couple answers to questions about the assignments. The dates, which are updated in some places on the web page on Blackboard, but not every place. The next project, which I believe is project 4, am I correct? Project 4 is due Sunday, the one that comes in about 5 days from now. 24th, I think it is. Yes, that's updated under Unit 9, but it's not updated under Unit 8. So I will try to go back and update it. Again, the weeks are off. Nobody accounted for the fall break, and so everything got shifted up. We'll have to cut something off near the end, but we'll figure that out later. Okay, so also I've updated the assignment. So not only do you play with TuneStore, but there's a real website that you have to log into. I did not tell you the password. Make sure you put your real student ID, because once you actually log into the thing, I'm going to take your student ID and put it into my database. And so I know that you've been there. If you don't put your real student ID, then I won't know it was you, and you probably won't get credit for doing it. We'll talk more about that a little bit later. And for ethics, this is my website. This is one I developed. It's a little Raspberry Pi upstairs in Professor Carr's office. And so you are invited to attack it. There's no problem, no ethical issue in attacking that website, because I created it for the purpose of you to attack. Okay, any other questions about the class? Okay, moving on then, maybe. All right, yes. Injections, a pretty serious problem. This is the OWASP. Let's see if I can remember what OWASP stands for, but it's an acronym. W is for web, web applications security. Yeah, anyway, it is a website of information and tools for keeping things secure. It's OWASP.org. It says so down at the bottom. OWASP.org, and they have their top 10 application security risks. So I've copied their top 10, and here it is. You'll notice that injection, which was #1 earlier, has dropped to #3, mostly because a lot of sites are aware of the problem, even though the problem was widespread. People are becoming more aware that this is a dangerous problem, and so they've been doing things to stop it, taking those precautions. And we'll talk about some of them today. We talked about lots of them on Monday. And there are several other things here as you probably understand. Number 10, server-side request forgery, will be talked about next week. Also, cross-site scripting. I don't know where cross-site scripting fits into this, but yes, but we'll find out. So just let you know, this is it. SQL injection and other injections are a problem. There are all sorts of injections. I went out and looked at a bunch of them. So, and I made this slide, and I said, "Oh wow, that's an acronym test." So let's go over some of these. As you all know, SQL, structured query language, that's normal database system that people use. There's no SQL, that's non-SQL type databases, which, as I commented before, most students use because they don't understand SQL. Non-SQL databases are like Google. Google searches through the text of documents, and you can put in keywords, and it will tell you what it's found. Google would not work at all with SQL because it's not that structured. On the other hand, most applications that you deal with are looking at structured data. If you have data that's tables that has user IDs and passwords, for Pete's sakes, do not use NoSQL. It's not what you're looking for. You want to use SQL. SQL, if your data neatly fits into tables of columns and rows. If it doesn't, if you're just searching arbitrary text, then NoSQL works really well for you. And you can, you're not any safer. You think you're using NoSQL, you're going to be safer against cross-site scripting. Nope, it's still vulnerable. We talked about OS command, injection, where you inject commands. I've been practicing with that a little bit. We'll talk about that near the end. LDAP. There's one. Anybody know what LDAP is? I hear silence. LDAP is lightweight directory application protocol or some other access protocol. P is for protocol, lightweight directory, something with an A protocol. I think it's, anyway, it's used to keep track of information about users on the web. In other words, if you have a single sign-on for all the applications on your web, you're probably using LDAP. It was developed mostly by Microsoft, and it's now become open source, and a lot of people use it. And got a language, and you can inject into it. Because a lot of times the information that they take to enter to create an LDAP entry when you create a node or something, you can do URLs, universal resource locators, or web links. A lot of things will build what you put it and put it into the web link. Well, you can mess that up too. And then there's XML, extended markup language. XML, if you all use XML, has lots of, well, it looks like HTML, but it's not HTML. It's a method of storing data. HTML is a method of presenting the information. XML is for storing data. And it's got lots of less than and greater than signs, lots of brackets. It's used a lot in JSON and SOAP. Those are two protocols that transfer their information. JSON may or may not use XML. It may use other things, but SOAP is XML. It's a scheme for transmitting data across there or storing data. So, and all of them can be subject to injection. I wrote a little application that uses XML and had to make sure, I mean, it was for me, not that I was thinking I was going to hack into my own application, but I had to make sure that whatever data I put into it wasn't going to screw up. If you put it in brackets and you put greater than less than signs in your data, then it can make a mess out of the XML file. So you have to, well, the easy way is to encode it. I just URL encoded everything, and it takes out all the nasty characters. You don't have to worry about it. When you read the data back in, you decode, and everything's happy. So again, injection, all different types, and it happens a lot. It's very common. SQL injection, of course, happens a lot because people use it a lot. People use SQL to keep track of information. That's where companies keep their data in a variety of SQL type databases usually. So that's what the hackers want to attack. That's where the information is. That's where you can make or place orders for free and stuff like that. So people want to attack your data. So it's pretty common to do SQL injection. Also, a lot of systems do logins. We'll talk a little bit about that. We talked about it on Monday. You're here. Okay. Here's what you're never ever supposed to do. This is what all sorts of systems seem to do this. Basically, this is sort of, this is PHP, well, 2 lines of PHP. You can tell because every variable name starts with a $sign. PHP's got a really primitive compiler. Well, no compiler, interpreter, it doesn't compile anything. And so we assume that some sort of user input is in the variable username. Now you're going to search that. And so we've got the select statement there. And got to watch the quotes. Here before username, let me see if I can make this work. Annotate. Okay, I never find. Oh. That is definitely not what I wanted to do. Well, I've been having, oh, undo, there we go. where is the, is it? Yes, at last. You see that, that's a single quote followed by a double quote. The double quote finishes the double quote you see over here. It's the end of a character string. You're defining a character string. And the single quote is actually data because SQL expects that this name is going to be surrounded by single quotes. So the final statement that SQL wants to see is going to be select star from students where name equals quote, student name quote. So those that say quote, so the quote is there. And again, at the end, there's another quote here so that the username, when concatenated, and the period in PHP means concatenate. You know, a lot of times you write an application using JavaScript on HTML and PHP on the server. It's a very common system. And it would make life a lot easier. Both of them use the same concatenate character. Because I continually get them mixed up. Okay, but here's a period. So we can concatenate this together. All right. And then you pass it off to SQL to parse and execute. Oh. Okay, there we go. So we have the same command there in the middle query, but now we're going to enter something in here. Like in this case, we're going to enter junk quote or quote X equals quote X, and then put that in here. And that's going to come out as we show down at the bottom where the select statement. Now the where is name equals junk or quote X equals quote X. Well, quote X equals quote X obviously is always true. You can use numbers, you can use strings. It's the same thing on both sides. And whenever you have the same thing on both sides of an equal sign, it's always true. And we all remember that in Boolean logic, true or true is always true, or true anything is always true. So once you have a true, an always true statement on one side of an or, it's always going to be true. So this is going to select from students where, well, skip the where name equals anything. So it's going to return all the students. So it's going to select all the rows. That's a lot of stuff. Now, a lot of programs, poorly coded programs, will do this. And then when they get a result, they'll check, well, how much did we get a row? Oh, basically, they're looking at, well, if they didn't get any rows, then the user ID or password are incorrect or not in the database. If they get a row, then it must be in the database. And just to make sure, in case for some reason it's there twice, they'll see if the number of rows is greater than 0. Okay, that's nice. But if you were to do the attack like this, where you're putting in something that's always true, you're going to always get all the rows, regardless of whatever name you put in, because the name doesn't matter. It's the X equals X is true, and true or whatever. It's always going to be true. So this is going to return all the rows, which I assume is more than nothing. So it's going to say, oh, good password, and away you go. You are logged in, even though you don't know anything about the user IDs and passwords. Now, SQL is terminated by a semicolon, although in most SQL statements I've written to run inside a program, I omit the semicolon at the end and it works just fine. I think when you come to the end of the line, it says, oh, you must be done. You can put a semicolon in there, like Java, C++ ends the line. Or you can put in comments. Again, dash is like a Java or C++ comment. It's a comment to the end of the line. It's important to note, and we'll see it a little bit later on, that there must be a space after the dash. In other words, you can't let the dash come up against a non-character, so a non-white space character. That'd be a tab, a space. You must have a white space after the dash. And I've got an attack later on where the space is important. If you don't put the space in, it doesn't work. Okay. Here is another example where this is what it was expected to be. We select where the price is, wherever the input was, and the owner is, we want to get around that secret thing. We don't know what the secret ID is, but we don't care. We would just like to be able to look at all the cheap stuff. So if we put it in an input where the input is 10, single quote, semicolon dash dash space, then that replaces the input. Well, because dash dash space is the start of a comment, everything else at the end of the line, so the and owner equals secret ID is omitted. It's considered a comment SQL, doesn't look at it, cruises right through, and so you get that with something that's select star where price is less than 10, and it doesn't even think about the owner. So again, it's SQL injection. We are executing some of it. This is all caused, of course, because we are concatenating user data with character strings in order to make information that will then be executed. Some systems allow you to execute multiple commands in one execution. When you go, yes, so if you tell SQL, well, we'll do this. Yes, here we told SQL to query that. You can execute multiple commands if they're in the line, separated by a semicolon. So here's an example. Same SQL statement as we saw just before, but now the input is 10 quote semicolon space drop table item. Item is the name of the table. For those not big with SQL, drop table is an SQL syntax to delete this file, delete the table item. So what this is going to do is it's going to do a query, find out what items have a price of less than 10. And then once it's done that, it's going to delete the table item being where we're searching this from. And now nobody else is going to say, you just deleted the database, or at least that table out of the database. And all future users will get an error because it's not there. Hopefully, your system administrators back this up on a regular basis because it's gone now. The obvious fix for this is to not allow the account that runs this the ability to delete tables. Drop table is a option. There's a couple dozen different capabilities you can give an account. There's a lengthy list of static and dynamic abilities you can give an account. Drop table is unfortunately default on. Everything is default on. And so if you create an account to do this, don't use root, don't use the administrator, create a new account and don't give it the ability to drop tables. And of course, don't concatenate strings together and execute the data. I might note, MySQL, a very popular free version of SQL, doesn't support the concept of executing multiple commands on one line, which I can understand. Not only is it help prevent some of the security problems, but it gets really messy when you try to understand what is it doing. What do you do if you do two selects and you have two outputs? Where do you put them? Blind SQL means you don't know what the SQL table looks like. You don't know what the queries look like. You're just trying to guess. And again, reconnaissance is an important part. We're going out there and looking at the system and seeing, giving it some inputs and seeing, well, what does it give us? What sort of results do we get? Can we figure out what kind of database are we dealing with? Is it susceptible to SQL injection? I mean, some of them may be fixed, but you might, if you can find out that yes, it is susceptible to SQL injection, then that's probably the way to go to try to hack into it. On the other hand, if you find out that no, it doesn't seem to do anything, then think of something else. Or you're just wasting your time. And here's an easy way to do it. Okay, so the simple version is we want to input by we're doing, again, simple little query, giving it a number. So we input the number 5 and it works just fine. Then we give it 5 or 1 equals 2. And that way, of course, 1 equals 2 is false. So it's 5 or false. So the price equals 5 has to be true to get something. So if you get the same result, and then you can go and both sides have to be true. And so if the 1 equals 2, which is obviously false, if that's false, then you don't get any results. So that way one of them works, one of them doesn't. And as long as you got something for 5, you got to, of course, make sure that 5 by itself, the legitimate answer of 5 works. And then the or 1 equals 2 should still work. And the and should not work. When that happens, you know that you're possible to do SQL injection. If, of course, they were doing this correctly and using parameterized statements, then that wouldn't happen. Either one would give you, well, actually, anything but the 5 itself would probably give you no results. I mentioned this a little bit. Those poor souls who had to suffer through me last semester teaching COMP725, the textbook, the first third of the textbook is on reconnaissance. Reconnaissance is making sure you understand what the site, all the information about the site that you are trying to attack. And it's a very important first step, because if you don't know anything about the site, it's going to be much more difficult to attack. And you have to think about not just the technical aspect, but what is this site trying to do? What are they protecting? You know, what is important to them? And do they protect what is important to them? Also, this is written by people who try to protect sites. So they think about, well, what is important to this company and do you protect it? So you try to gather as much information as you can. I like this quote that I got from the book, was web application reconnaissance is about generating a deeper understanding of a target web application. That's an awful lot about what does it do? How does it do it? What sort of software tools are they using? And then if you know that, it makes it much easier for you to attack. Another one of the things you can do to help defend your database is to not make it available online. Don't attach it to the internet. There's some system, your web server has an attachment to the internet, and then it has an attachment to another system behind it that you connect to, but not through the internet. So in other words, you can't directly get to the database server. You can get to the web server. The web server accesses the database. You can also configure the database to not just send it SQL commands, but send it function requests. Move up in the software layer up a little bit. Do you need a list of, do you want to check if this password is correct? Well, just send a request saying, is password correct? Just send the password and sends back a true or false. That way, it doesn't matter. You aren't giving it the SQL stuff. And again, use encryption, transport layers. So that's like SSL. That's what you get HTTPS. It creates a secure encrypted channel between machines. And only let it connect to machines, the local host at this machine, or machines that you specify, machines that are behind your firewall. I think I mentioned this. Also, this tool, phpMyAdmin. I don't know if you use SQL, particularly MySQL, phpMyAdmin is very little about PHP. It's all about your SQL database. But it's the tool that you use to create tables, to modify them, to set the parameters, to create accounts. It's a very useful tool. And so because it's so useful, you don't want attackers using it. So you want to make sure you protect that. More than just the user ID and password that comes with it. Okay. And the usual thing about passwords, of course, use big passwords that are random characters. They are, of course, hard to remember. You have to figure out about that. I'll talk about passwords later on, but not today. Okay, and then your database should only contain information for one application. Don't spread them around, otherwise people can hack into multiple applications all at once. Oh, I think I mentioned before that when you log into a database, you have to give it, or when you have a PHP program that's going to access the database, the first thing you have to do is say, I want to connect, and you have to give it a user ID, password, name of the database, and probably something else. But that information should not be in the source code of your program. It's best in PHP or whatever language you're using to do an include. Like a PHP, you can just do a pounding, $ include, and tell it to go out and get a command and put that file that has someplace not in the reach of the web server. There's typically your web server accesses a certain directory. And when I create something with Apache web server, it's www/html is the direct. It's var/www.html is a directory. Then you put all your stuff there. That's the home directory of your website. And you put everything in there. If you put this file with the configuration information outside of that directory, the web server will never see it. There's no access to the web server to get that. But programs that run like PHP, they can access anything. So they can access the file someplace else. So they can pull in that file, get the information they need, and not make it available on the web. And of course, as I mentioned before, if you go out there and allow people to execute data, we're talking about SQL injection and command injection, cross-site scripting, which is XSS, cross-site request F, whatever that is. That's next week's topics. Next week, we're talking about attacking the users, and that's XSS. Oh, request forgery. Yes, cross-site request forgery. There's a lot of acronyms in this business. And those, all of them involve somehow fooling the system into executing user data, interpreting something that you've entered as either JavaScript or PHP or whatever. PHP mixes text, HTML command, and JavaScript also mixes these things together. And as I mentioned, to those of you who are going out in the world and have a chance to make these things, don't do it like that. You know, my example is Microsoft Word or all the Microsoft products for the Office products. You don't see the markup. Now, if I want to make this bold, you don't see the word bold here. The commands are not with the data. So yes, we don't have to make systems where we're executing the user data. We could be safer. Of course, if you use the systems properly, you don't execute the data. But we shouldn't have made it work like that in the first place. Okay. All right, I have an example we're going to show in a few minutes. This is going to be a short class. If you don't like it being short, you can stay on and leave. Okay. Let's imagine we have a site that's going to create new users. And we create the user, we have privilege level. Privilege level 2 is regular users. Privilege level 1 is an administrator. And so the PHP application has this command here, insert into accounts, which is the table name, privileges, and then there's two columns, username and privilege, values, and then you'll note that the double quotes here indicate a character string, and then period username, which is data that the application got from the website, and then I used different looking single quotes because when you put the single quotes next to double quotes, you can't tell which one's which. But yes, it's a single quote because again, expects the username to be surrounded by single quotes. And then 2. I might point out that the 2 being an integer can be in quotes in Java, or excuse me, SQL will gladly accept it, or you can just leave off the quotes, put it as a single value 2 as an integer 2, and SQL will be equally happy. So let's give it a try. Let's see if this, I'm going to have to adjust the sharing here for the folks online, so bear with me. We're going to share. That's not at all what I wanted to see, but okay, hopefully you can see it. Let me go up here and make this bigger so we can, there. Okay, you can actually read what that says. This is that application. This, by the way, this is again on my server, williams.comp.ncat.edu /COMP725, where I am slowly putting information about this class. And so this one wants you to do it. This is a relatively simple HTML with JavaScript. It has 2 functions. One to enter a new user ID, and it calls one PHP application on the server to do that one. Or if you say list the users, it calls another application which displays them. Easy enough. I put this together this morning, and like any good programmer, I didn't start it from scratch. I took an existing application, cut it up a bit, and I made it work, which is why when you see it print things, it prints 3 columns, because the other application printed 3 columns of information. It's just so much easier to duplicate one of them. I was having quote and double quote problems, so I said, oh, forget it, we'll just display it twice. So let's try that. We want to enter, well, where's my mouse? And enter, okay. We'll just put in, Sally wants to be a new user. Submit, okay. And now we go down here and say, let me show the users. And if we look at all the users, hey, there's Sally with privilege level 2. And again, because it was just easier to show it twice and get rid of it. All right, now, how can we create Sally with there's the SQL. Okay, folks, online and here in person, what should we enter to this database in order to give somebody privilege level 1? Looking for solutions. Anybody want to try something?
Single quote, 1.
We're going to do a unique name, by the way, because it will be upset if we put a name in twice, but we'll give it Aggie. Then
Then single quote,
single quote,
then 1,
then 1,
and then again single quote, and comment the rest. So
dash dash.
and
Not so sure it's going to work. No, that didn't fly. Let's take a look. That's an interesting try. Okay, what do we need this to look like? We need to be username, it's quote, username, quote, comma, either quote 2 or just 1, parentheses. And then, of course, if we're going to get rid of stuff at the end, we might need to put in the dash dash space. So anybody else want to try? That's a close, it almost works. Anybody else want to, how can we modify this to work?
maybe we can put a colon before 1. Probably that's ignored.
Mr. Hernandez, since I had you in so many classes, you poor soul, what do I do? What are we going to how are we going to do to fix this? We'll go back and look at the SQL. Okay, let's go back and look at the SQL. There it is. Yeah, so we need it to look like this, but with putting something in here. And then we want to replace the end of it, which is basically quote, comma, 1, parentheses. You got to make sure it comes out with correct syntax, or else it's going to be upset and you're going to get a 500, doesn't work error. You got to guess?
Instead of dash, could we, in between the dash, could we end at the end, before and after the 1, could we put a comma?
Yeah, we got to put a comma here. Space, make it really pretty. That's a good start.
And then quotation marks around the 1 inside of it.
Like that. I'm going to recommend too a parentheses, because if you look at the statement, there is a parentheses in the end. You've got to make sure you get the parentheses. You got to make something that's going to have good. Now this isn't going to work. Tell you one way that you can tell. When you're doing SQL, you had matching quotes. You're assuming that if you did it the normal way, all the quotes that match up. We're going to have a string that's going to be parsed by SQL. If you're going to add a quote, you got to add 2 quotes. You have to have an even number of quotes in your statement. Otherwise, you're going to end up with a syntax error with the string. So in any attack, an even number of quotes. You see why? Because if you add 1, there were matching quotes. Every time you have a left, you have a right. Well, quotes look the same, but you left and a right. If you put an extra one in there, it's going to be a syntax error. So you got to put an even number of them so they balance out. Okay, so I think you don't really need the quotes there. And I think if I, let's see, the quote on the end, space, quote, does that work? Oh, ooh, that did. So let's look at this. It's Aggies, quote, comma, 1. So that's going to, again, we're looking for this. It's going to be the username, we're surrounded by quotes, comma, number 1, parentheses, back to that. And then the dash dash. So it says, okay, ignore everything else. But the quote in the end, if you don't put the quote in the end, I guess it would work. Does that work? No, that doesn't work because you get a syntax error, even though the SQL is right. You mismatch the quote when you're putting together a string. And so in the big picture, when you look at when SQL looks at this, there's a mismatch in quote, and that's real, that's a syntax error. And I guess and that error 500, if you don't remember your HTTP error codes, 500 says server did something wrong. And in this case, the SQL didn't work. Okay, but I think we got it. If we go down here and go click submit, and yes, there we have Aggie and Aggies plural. Got them both, and they have privilege level 1. So everybody see how that's done? That's basically how you do it. I want to make a comment. I showed this slide on Monday. This is command injection. And I mentioned when you execute a system command, like you know, in this example, instead of making their own editor, they're going to call Notepad for you to update a file. And then when you exit, they'll know the application is terminated, and they'll go out and get the file and see what you did. In Linux, Unix, and Microsoft command line or DOS, if you put an ampersand out there, you can put in 2 commands. So if you write Notepad space myfile.txt ampersand evil command, it will, and you put that into a command.com, and you execute that in the command, the black command box, it will call Notepad and also execute the command. But in my efforts to do that this morning with, I had a little simple program in Java, it did not work. I called Notepad, and I didn't put a file name there. Just Notepad popped up, but then it says ampersand's not a file. You know, it doesn't know about a file. Can't find the file ampersand. Can't find the file evil. Can't find the file command. Or actually, I had real commands. I was doing my evil command was just to make directories. Just make directory makes a directory, and I can see if it did. You know, because you're not going to see any output. But if I made a directory, I can go back and see, does that new directory exist? Aha, it worked. But this just Notepad looks at all, Notepad gets all of these and complains about the other things and thinks you're trying to access multiple files and it doesn't know about this file. So I had no luck in doing that. So I don't know if anybody else can make that work. I'm interested in knowing how to do it, but I couldn't get it to run. Of course, I was trying it on Java. You can do it with C++ or C. It's the exec command in C or C++. Exec V or exec. There's about half a dozen exec versions, depending on how you pass the parameters. One of them is you pass it the name of the file that you want to execute and an array of the command line parameters. Because when you run this in a Java program or C++ program, you get the, in Java, public static void main parentheses string bracket, that's an array of strings. And one way is to pass it the array of strings. That way, there's no parsing this. It won't do any possible multiple commands because you're giving it just a list of parameters. Another way to pass it is just give it a string like you expect. But I could not get that to do anything evil. How disappointing. All right. That's all of my slides for today. Yes, sir.
This PowerPoint, are you putting this on Blackboard?
I will. Yes. Well, I finished it, oh, about an hour ago. So I didn't quite get it out there. I got it, yes. I will make sure I put these PowerPoints out. I apologize, they're not out there now. I should have got that. As I was driving in, I thought about that. But I thought it best not to try to do it while I was driving, so there's one thing to do text from your phone, it's completely another thing, to open up your laptop and try to do something. So, okay, yes, you're correct. I missed that, and I'll try to get that. And of course, this program, which is linked to in the PowerPoint, is available for anybody to play around. The assignment, the quiz for this week for Unit 9 has the usual online Blackboard questions. There are 33 of them, I believe, instead of the usual 36, each worth 2.77 points. And that leaves us about 8 or 9 points for the attacking the other website or the other program on my website. And again, you're invited to do that. It's not an ethical issue. It's my website. I made it for you to do this. Okay. Any questions about the project? This is we're doing project 4. Yes, project 4. Project 5 is listed in the unit, but that's not due to this one. Again, the dates are wrong. I will go out and fix the dates because everything got a little bit weird. Okay. So that's it for now. Anybody have any further questions about cross-site scripting or the course or any of the Okay, it's short, we're half an hour short, but if you don't like it, I'm going to leave. You can stay here for half an hour. Okay, thank you very much. And I'll try to get more organized. We'll do this next time.
Take care.
Mouse. Oh, my
Thank
mouse.
you. Bye-bye.
Bye, thank you.
Hey, thank you. Stop.